Okay, so moving forward, okay, as we look at approximately what we're doing this week, we'll have an assignment for you to work on. I do have your first papers graded. I just have to get them into the grade book. And then tomorrow, what about tomorrow? Okay, it's just over your vocab terms. Okay, so make sure some of us who maybe don't have them done, get those completed because we don't want you to leave, what would we say? I always like to say leave points on the field, on the table. So to put that into perspective, we could say Minnesota yesterday, yes, I do pull for Minnesota. I thank their lucky stars that they won because they got extremely lucky, I would say, in the second half. And the reason I say don't leave points on the table is not that Green Bay did. It's just that I wouldn't say that they settled for field goals, but and they missed 2 field goals. And sometimes what can happen is, should it be fourth down, and that's what it takes to be a coach. Do you go for it on fourth down and then try to continue to get 6 points instead of 3? Sometimes that's the best decision. Sometimes it's not. But should you go for it on fourth down, you don't make it, and you find yourself down by 2 points or 3 points at the end of a game, well, you left those points on the table. Well, that's just one way of looking at it. But what I mean is take advantage of these opportunities. That vocabulary we like to think is, it's not that it's free points. Hopefully we can look at it as being easy points. So, like over the weekend, I was talking to the seniors a little bit about this. Volleyball. Are we upset with Saturday? Yes? No? Can you answer that? What's your impression? Okay, well, just didn't play well. Okay, and sometimes that unfortunately does happen. So that's what we have coming forward. Some of us who are behind, it's your responsibility to get caught up then. Okay, so refresh my memory approximately where we have left off. There are what we consider 4 forces. The one we spend the most time on is actually it's considered the weakest force, even though it's not called the weak force. And I know that sounds redundant. But yes, we spent the most time on gravity. And when we talk about Newton's second law, the first one we would say is the law of inertia, okay? And it's always stated a body at rest will stay there unless it's acted upon by an outside force. We've discussed that. That's why our racetracks have embankments built up around them, around the curves. Well, true. Because the speed of that vehicle going around the curve, it wants to flip right over top of that wall because that inertia is causing it to go forward. So that was Newton's first law. Newton's second law deals with gravitation. And then Newton's third law is an equal and opposite force. So is this where we start then? Seems to me like we talked about this, right? Needs sliding friction. Okay, there we go. When we look at friction, does it have its advantages? Well, of course. If you do woodworking, the best example of what type of friction would we be talking about? Think of woodworking. So when it comes to smooth surfaces in woodworking, let's go with that. What might cause that? Or what might you do to have a smooth surface? Does anyone do woodworking in here or seen woodworking done? What would you possibly do then? If you want a nice smooth surface when you're doing with woodworking, yeah, you'd use a piece of sandpaper or a sander, which comes in, of course, many different types. You have orbital sanders. That's just what comes to mind. Say that again?
Sandpaper blocks.
Yes, again, we're actually doing it by hand. I actually have a sander that you actually hold with two hands. It's not that it's really all that big, but it's got a motor in it that causes it to rotate on a belt. And, belt sander. I can't believe I didn't think of that. Yes, a belt sander. Okay? So since we are in the middle of a harvest season, it would appear that this is before your time. Gravity wagons used to be used to haul grain from point A to point B, whether it's from the field back to the farm, or and some still are, and maybe you're hauling it from your farm to the grain elevator, or the ethanol plant, wherever. We're not concerned with where we're going. Okay? So if we have, let's say, two 500 bushel wagons that are fully loaded, we'll say weighs 15 to 20,000 pounds. It could be heavier than that. I really don't know. Is your little lawn tractor going to be able to pull that? No. So that is static friction because there's no movement. Okay? Even if you do move that, yes, there's still going to be some sort of friction that takes place between the wheel and the ground, but you have to have a bigger tractor or something larger to actually pull that. So when you have two surfaces coming in contact, sometimes you can actually use a small tractor to move some of these really large wagons, even if they're fully loaded. You probably just can't go that fast. But you can move, like I said, just not very efficiently. Yep. Okay. So when we look at this, we could say that this is a trick question, okay? When you're driving, what stops your vehicle?
Brakes. Clutch. Friction.
Okay? It has something to do with friction. Yes, the brakes will slow your wheels down. That is true. So there's friction between the brake pads and the drum, or I don't know, I'm not a mechanic, but I think you call it the drum, and the rotors in maybe your front wheels. Okay? But your brakes stop the tires, and the tires is what actually it has contact with the ground, and that's how you actually come to a stop. Yes, you're moving forward, and I know, yeah, it's a fine definition. No, the brakes stop your vehicle. Well, yes, they do, but it has happened a couple times where, does anyone have to drive eastward at about 7:30 in the morning? If you're lucky, you have to drive west, and eventually it's getting a little better. You don't have to look into the sun, but what I'm getting at is it's happened a couple times where driving this big bus around, if a deer darts in front of the road, and you slam on your brakes, yes, you're going to slow down because your wheels are slowing down. But if you skid, your brakes are not stopping you. It has something to do with it. Your brakes stop the wheels, and then the friction between the wheels and the ground is how you actually come to a stop. Okay? And one of the things that sometimes would, when I'd be hauling grain, this is probably when I was about your age, and would maybe help my cousin's farm too. And then after getting weighed on the scale, and then having to go through the town of Larchwood to go to the place where you're going to actually unload, you're going down a bit of a hill. If there's traffic coming, and you push the clutch in, and you slam on those brakes, your back tires are bound up. They are stopped, but yet you keep on going. Well, if the tires have stopped, why are you keeping on going?
Heavy of a load.
The heavy load is continuing to push you forward. Okay? So that's what we're trying to illustrate. The tires are stopped. It's the friction between the tires and the ground that actually slow you down. Okay. Yes. Yes. Okay, I want to wrap this up. We're probably oh no, we're not quite done yet. Because I want to get to gravity. And then, so there's JV football today, right? Yep. Is there volleyball too? Or is that, that's next Monday, you're in Chester. Okay, all right. I know. Long ways to go to Castlewood. Okay, let's see here. Let's see here. 1, 2. Oh, we are almost done. I was just looking at how many slides we have. Let's get this wrapped up today then. Okay, well, it's probably because we ran out of room, so you do have space at the bottom. I would encourage you to write that in, because there's not a lot left. I probably just didn't want to waste an entire sheet of paper, so that's why you don't have that. At least make sure you're writing the definitions in here. So, trying to think of how to describe this. I think I don't know the technical term for this, but some of you who are farmers, the very first type of semi-tractors that came out, where you're actually sitting on top of the engine, and it's
Cab over.
okay. I didn't know what it was called. Okay, so cab over. Okay. So why, in your estimation, and I understand, why not just make the cab over trucks bigger? How, when you look at semi-truck tractor, did you say tractors or trucks?
Semis.
Just semis? Okay, so we're all talking about the same thing. Okay. So when it comes to these semis, Why do they look different now than as opposed to the cab overs, do you think?
The engine in the front.
Yeah, I know the engine is front. Why would that possibly be an advantage to having a cab over?
Cab overs are hard to work with.
Well,
gotta-
probably.
you gotta-
I bet you they're cheaper.
Lift the cab to work on the engine.
Right. I bet you it's still cheaper to have a cab over than it is a bigger semi.
More forward weight than there's.
That's true. But think of the aerodynamics. A cab over is just basically
It's
a big box going down the road. Would you agree with that?
yeah.
So when you look at whether it's modern semis, we know that the engine is in front. Which one has more air resistance, the cab over or more modern semis?
Modern.
Why might it be the cab over?
Because a box, you're going to have air resistance straight.
You're going to have a lot more drag or air resistance with these cab overs, okay? So what does it mean to streamline something? Do you think? Because we've already established this, determines how fast an object will accelerate. You said with a cab over, it's just like a big box rolling down the road. That's not very aerodynamic.
No, because the wind's just gonna stop.
Well, it'll
It's gonna slow you
have,
down fast.
right, and that's what we call air resistance. So now, when I suppose you could say that we copy what nature has already done, like the snout of a shark. Is it pointed or is it blunt? Is it rounded or is it square?
Rounded.
Yeah, it's rounded because that provides less drag or produces less drag, okay? So although that's not air resistance, that would be water resistance, but the same type of concept would apply. The more streamlined that you can make something, that means the faster it's going to be able to move because of decreasing that resistance. And that's why when you look at different types of boats, it's not a big box going through there. When you look at the front of a boat, yeah, it actually looks like coming to a V. So that actually cuts through the water. Okay? Now, when you get into submarines, I suppose that's a little different, but not for the reason that you might think. Why not have a submarine come to a point? It'll certainly move through the water better. So if the front of the submarine comes to a point like modern ships do, why would it be rounded instead? Because what do submarines actually do?
Go underwater.
Make it so you can be inside of it.
So when you go down, it's something that we're going to see when we start talking about the arch. The reason that you don't have submarines come to a point is because they're going to depths that have really never been reached before. And the further down in the water you go, what happens to the pressure? It gets a lot higher. And what was, oh shoot. It was one of the latest, I don't want to say trips down to see the Titanic. It was a couple of years. Was it Titanus or something like that?
Ocean Blue.
Was that the name of it? Ocean Blue?
I think it was Ocean Blue.
The submarine that brought like people down.
Yes.
Yeah, Ocean Blue.
Oh, okay. So Ocean Blue. So whether something structurally failed inside of there, which it must have, because that should be able to handle that pressure going down that deep. And that's why you see the hulls of these submarines come to a circle like this, because that can withstand and that will not collapse, unlike its predecessors like this that had a hull shaped like this. Okay, so finally, so these are some of the forces that we go over. Okay, something will weigh more. The larger the mass, it's certainly going to weigh more. That's why we had said like 500 bushel wagons. The mass of them is much, much larger than what we had when we were growing up, which was around 250 bushel wagons, which we thought were large at the time. So the larger the mass, the larger the weight. So why would those wagons may weigh more? Is it just because there's more materials in it?
Because they're made of.
Well, the components have nothing to do with it. You have more mass. The larger the mass, you have more gravity acting upon that structure. And that's why that would be so much heavier. Yes?
Can I go to the bathroom?
Yes. You know, if I was sitting where you were, and how could you not know what a cab? I honestly did not know that's what they were called, and you'd be right saying, how did you not know that?
It's something that you put your caps on.
It's a semi.
Oh, I didn't know that.
Basically, like,
I was gonna
you can put your jackets on.
Hold on. When we're done with this, can you look up a cab over so Levi can see?
Yeah.
You know, we can really be. I got a better example than that. Vintage Optimus Prime.
Oh, I saw the
So now I know
Optimus
what a
Prime
cab.
movie
I know
yesterday.
what a cab
That's
over
crazy.
is now.
I saw
Mhm.
the Transformers 1 yesterday.
I know what a cab over is now. You just have to say
Yeah,
that.
Alexa was.
Yeah, but
relaxed.
how do you know what Vintage Optimus Prime means?
Because I've watched every movie.
Yeah, but that's not the same. Yes, what?
Negative three.
When he comes back.
Can I go to the bathroom after Weston?
When I come back.
I was gonna ask.
But when you say these newer Optimus Prime,
He's like.
that's not the cab over. The cab over was, when I say vintage, back in the 70s and 80s in those cartoons. That's where he had a flat front called the cab over. We'll maybe do that some other time. We're not concerned about that right now.
Or you can just look it up on your own.
Yeah, you can look it up on your own time. Okay, so your different forces, okay? Here is 1, here's 2, here's 3, and then when we say gravity, it's saying that is one of the forces as well. Because we know it has something to do with force, because it equals mass times acceleration. And that acceleration is due to gravity, and that's why we throw it in with the rest of the forces. Although this is more so next semester, okay? And we can show you a quick example of that. You probably have seen this before, just didn't realize that that's what we were referring to. And actually, it's tied into much to that structure that's in front of Mrs. Herbert. It has the stick models of 2 carbon atoms, 5 hydrogen atoms, and 1 chlorine atom. Although that's more so for the senior level class than what it is here. Mm-hmm. Okay, then
What if you don't have no more room on that page?
how large are we writing? That's why. Okay. Just write it in your notebook paper then, like Mrs. Herbert said. Yep. Does everyone have this content that wants it? Okay, then finally we wrap it up with this.
Actually, can I have one of your
What do you race?
go-karts?
Go-karts?
They're fast.
Like big ones?
Yeah.
Have you won?
Yeah.
How many times?
Four.
Who you race against?
Me.
People.
Are they good?
Yeah, some of them.
Are you better than them?
Sometimes.
Yeah. It all depends on the card, pretty much.
Why did you spin out?
Because I got spun out by other people.
Why didn't you get out of your car?
Because
Why didn't it start on fire?
What?
that was fun. Okay, funny story.
Yo.
Funny story about that.
Okay, does everyone have this content that wants it?
During a race,
Okay, we got it? Okay. So, like I said, a lot of this maybe pertains to next semester, but the author puts this in here. So, we'll just, now you don't need to write this down, okay? Because this is the nucleus of an atom, okay? We're not done yet, okay? So inside the nucleus of this atom, you'd have 3 protons, okay? So what is it that will keep them protons from coming in contact with one another? Yeah, I wouldn't expect you to know either, but we did just write it down.
Force.
What force would keep those protons from colliding with one another? A strong force, okay? Because what happens is, okay, now you might say, well, these protons are colliding with one another. No, they're just overlapping in 3 dimensions is what that's showing. So on the left we have lithium with an atomic number of 3, and on the right we have beryllium with an atomic number of 4. Okay? Do we remember talking about this last year when you spent some time in here with the periodic table?
Yeah. A little bit.
You still have that periodic table? Okay, but anyway, what happens is outside that nucleus, you have these rotating around. Those are called electrons. So what force deals with electrons? The electromagnetic force. And what that does, even though we don't have all 3 of them in the same level, it's just easier to deal with that. So it is a type of force. We don't do that in physics right now. Like I said, it's more so of a chemistry application, but that's okay. Then the third type of force would be, okay, if you have a proton and you bombard that with a lot of energy, no, not a proton, a neutron, sorry. You bombard that with a lot of energy, now you have that split to a proton and an electron. And what force might that be? It's not gravity. It's not the strong force. It's not the electromagnetic force. It's the weak force. What does the weak force tell you?
Neutrons split, forming a proton and
Just like what we had established here. This, even though this is nuclear chemistry, we say chemistry, it takes physics to do this, okay? And then finally, what might the fourth force be? It's the weakest of all, and not the weak force here, but it's the weakest of all four. It starts with a G, and it's gravity. Okay, I'm going to hit pause here for just a moment. Okay, so one of the things we can, since we talked about sharks, okay, flip that over to the back page. Okay? It says, what is the mass of a bull shark if it strikes with a force of 6,069 newtons? In the distance, the shark spotted a fur seal and made a break for it, moving from 10.35 meters per second to 17.85 meters per second in 3 seconds. What is the momentum placed into the seal from the shark? Okay, so we're up to 15 now, I think. You've read the problem. Yes. Oh, yes, you're supposed to get those. I'm sorry. I was just so excited to talk about this shark, that's why. Okay? Okay. So like we said, probably we're up to 15 times now. You've read the problem. What's the next thing that you should do? I don't know if you will do, because some of you still choose not to do this. Do we want to work on this together or no?
Yes.
I mean, that's fine if we don't.
figure out what you have.
Okay, so what do we know in this problem? Well, it's not initial, it's just a force. Okay, so we have 6,069 newtons. What else do we know? Okay. Okay, so we'll just go ahead and label that in meters per second. What else do we know? I didn't mean to write F like that. Okay. 17.85. Okay, what else do we know in the problem? Okay, so it was over a time frame of 3 seconds. Okay? So, what is the question asking? Okay, so what's our variable for momentum? So that's what we're looking for. So with this information, okay, you're correct when you say we need to have the mass first. But we can't even solve for the mass yet, because what's your formula for momentum? Okay, so here's our formula. We're looking for this. We don't have that variable. And we do have the final velocity. But we've got two unknowns in this equation. So someone had correctly said, I think, but we just want to make sure everyone's getting caught up here. If we're looking for this, we have to find what that mass is. And how could we do that with our given information here? With other formulas, where else do you see the variable mass? Okay, so if we look at our force formula, we're getting closer. We have the force, we don't have the mass, but we couldn't solve for mass in that top equation. Is there something in the force formula that will help us? can we find the acceleration? Yes, that we can do. So we have to find the acceleration now. Okay? Because we want to find that mass as well. Okay. All right. So what does the acceleration formula tell you to do?
Minus df minus bi over time.
So what's on the right-hand side of this equation? Is that it? Okay.
Over 3.
Okay. Do we want to divide by 3 right away?
No.
So we have to put these in. I mean, it's not that you have to put them in parentheses. You just have to know that you need to subtract them first. So we have this fraction. Let's cross multiply, right? Get rid of the fraction. Isn't that what we do? We got a fraction. Let's get rid of it. You're correct when you say no, but why are you right though?
Because you're looking for acceleration, you're not trying to find.
Yeah. We're not trying to find any of these variables. Then we'd have to get rid of our fraction, but we can just go ahead and solve for acceleration. And what do we get for an acceleration? How much? 2.5. What? It's 2.50 what though? Meters per second squared. There's one answer. Now we can take this. We've got our acceleration. Now we can find that mass that we're looking for. So how do we continue moving forward with this? Now we're in our force formula. So we have an equal sign. What's on the left-hand side of our force formula? 6,096. Is that right? Okay. Then what's on the right-hand side?
It's 69, not 96.
Okay.
Jeez, Caleb. Maybe you should tell him right. Caleb, you solved it. Well, maybe you should learn how to say numbers.
Sorry, I was.
Okay. What's on the right-hand side then? According to this,
M and 45.
mass times 2.5, or if you flip-flop them around, that's just a variable. How do we get m all by itself? Okay. Divide each side by 2.50. What is our mass now?
6.276.
Isn't it? It's got to be bigger than that. 2023? No, I divide by 3, sorry. $2,427. .60 kilograms. Now you can solve for the rest. All right. That's all I have. We'll catch up to you next time. These are due October 2nd. Vocabulary evaluation tomorrow. We'll catch up to you next time.